Thank you so much, Professor Schneider, for giving the global view of water research and sharing such a wonderful insight and extensive work. We have nearly 26 questions, and I'm sure we cannot take all, so I'll just do some picking. And you have time till 12:30, right? So we have nearly 20 minutes of question. Awesome. So the first question on behalf of one of the researcher here we have, they're asking what are the major problems in desalination of seawater? Is there a possibility Singapore opt for this technology instead of buying it from Malaysia?
It's a great question. So we are very keen on ocean desalination. So we already have built several desalination facilities. We're building a new one right now that'll be quite large. But the challenge is really the energy. So even today, desalination is extremely energy intensive. So we opt in Singapore, and I think now in California too, we try to do water recycling first, which is converting our wastewater back into safe drinking water because it uses far less energy than ocean desalination. And we've also seen around the country of Singapore, the ocean's water quality is changing. And it's getting harder to treat. It's becoming more loaded with algae, for instance. So it's definitely part of the portfolio. It doesn't answer all the questions, but the energy intensity is the limiting factor right now.
Sure. And a similar question, which is about condensing the moisture. Like in India, Chennai, we have a heavy humidity there. Similarly, Singapore also is quite a humid atmosphere. How about condensing water vapor from the air? In India, there is a startup in Chennai. So what is the feasibility or your thought onto that particular technology to address this concern?
Okay. Another great question, and I'd love to see some publications on this. So the people asking the question, I encourage you to submit a paper. It's a great idea. In fact, you know, any of the aircon systems that we have here in Singapore produce a lot of water, sometimes a nuisance causing even damage. So condensing the water is great, especially if you have what I'd call waste cooling. You know, with waste heat, there's other things we can do, but in cooling systems, we get condensation that we can capture, and it's brutally humid here in Singapore. So we are exploring that. I don't think we would be building dedicated condensing, but when we have the opportunity, such as aircon systems, to harvest that water, it's definitely a good idea. So I think it's great. There are other people looking at how to absorb water vapor onto a solid phase, then to release that through different types of desiccants. So it's a great way, and we are certainly interested to look at it, maybe partner with anyone on the call who's interested as well.
Sure. The next question I have is, how do you see bioenergy as a part of remediation approach for these type of contaminations?
Another absolutely excellent question. So we are extremely keen about bioenergy. In fact, as was said in my introduction, we do a lot of philanthropic work. We built a system in Indonesia that captures waste from tofu factories and converts that into biogas. It provides energy for 90 houses in that region. We have 2 new intellectual properties we're testing here in Singapore, where we can get a 65% gain in biogas from our sludge and about a 70% reduction in sludge volume. So it is really a critical area for study. And at that kind of digestion rates, in terms of the contaminants, I think most of the contaminants, other than highly resilient ones, are in fact degraded as we're going through methagenesis. So it's another excellent topic. I strongly support bioenergy, especially in waste that would otherwise enter the environment. It's a great way to recycle.
Mm-hmm. Another question is about electrochemical sensing. So what's the status of electrochemical sensor in on-site monitoring of organic pollutants in river and sea?
So in the journal, we've seen some good submissions around electrochemical sensing. We would love to have better electrochemical sensing. I'll give you just a quick example is in this idea of recycling our wastewater back to drinking water, anything that gets through the wastewater system, like a solvent, like via volatile organic compounds, creates a terrible headache because it can go through the membranes and go into the drinking water and cause contamination. So I think that there's a lot of opportunity in electrochemical sensing. I would say for Singapore, I'm particularly interested in volatile organic compound sensing. So again, anyone on the call watching that has that kind of technology, please reach out, because our government would be keen to implement. So I think there's a big role that will play.
Mm-hmm. And this is more operational, I would say, a process question, more like a researcher curiosity. So someone who is starting wastewater analysis, should they start as a blind analysis or should have a specific impurity in mind based on the wastewater I'm analyzing? What is your tip like for someone who is beginning into this area, like the best practices, if you say?
Yeah, that's another excellent question. So first of all, I would suggest looking at, the guideline values. What are the major concerns for the discharge? It depends on where the discharge is going, if it's in the ocean or in a river or into the groundwater. But I would usually recommend starting with the primary, WHO guideline type stuff. But you can also think of it deeper depending on the source. So for instance, we have one of our wastewater plants which receives a very high industrial input from our refinery island, from some metal work. So we kind of know that that's going to have contamination from petroleum industry activities and metals. So kind of having some background information of what the source water is to that system could be a big help. But at the end of the day, targeted analysis is usually the beginning. But I am, as I said, advocating for bioassays, and it's actually a lot less expensive than people think compared to high resolution mass spectrometry, which is extremely expensive. But I start with guidelines, but think about the toxicity testing, because that's a great way to get perhaps the most important information.
Mm-hmm. Another quite interesting question here: what should be an ideal frequency of water quality audit? And add on to that, can we say that allopathic drugs coming out of from urine are more dangerous for water? So quite an imagination, but I think quite relevant questions as well.
So the frequency is another tricky one, because we have to think about economics, what's feasible. Here in Singapore, we're doing COVID testing in the sewer, and we had to deal with that question: how frequently will we have to test? I advocate for compositing if possible. So we put in composite samplers that can composite over 24 hours and do automation in terms of getting the samples we need. So it really comes down to resources at the end of the day, but it would be best, I think, if you can composite, not without its own problems in storage and degradation, et cetera. Check the blanks, QA, QC. But the second part of that question on, what's, I think, the most relevant, in terms of drugs and pharmaceuticals, again, it's really hard to say. It depends on the impact, or again, where you're discharging. Our studies were really geared around fish. So the idea was mostly around environmental impact to fish population, in which case we found the estrogens were very relevant. And as I showed, a paper from Canada demonstrated parts per trillion of the estrogens could cause entire species to go extinct. So very dramatic impact. But it depends. When we're recycling our water for drinking water, maybe the fish issue is less of a concern. But I think it really comes down to what you're trying to protect against. But I think the only way to really know the total toxicity, again, is with a bioassay system.
Okay. So now I have two questions on ozone. Someone is asking, is there any side effect of ozone during membrane separation process? And how much quantity of water can be treated by ozone so that the process become affordable? So that's more about the safety and the cost aspect, I think.
So ozone is one of my favorite technologies. I've been working with it my whole career, and it is incredibly good for disinfection. And so I think a really important point for the audience is, always put disinfection first, in my opinion, because people have died acutely from pathogens. So we do need to disinfect. I strongly believe that. But it is certainly true that ozone can form bromate, is the most commonly explored byproduct. And today I showed an example of nitrosodimethylamine. So it becomes that delicate balancing act between oxidizing enough to destroy the pathogens and maybe chemical contaminants, but not overdosing to the point where we're forming cancer-causing byproducts. One of the main things that I advocate, many advocate for ozone, is to have biofiltration after the ozone process. And the biofiltration process is extremely good at removing the majority of the byproducts that are formed. So that combination is a quite strong one. The ozone actually makes the carbon more readily assimilable by bacteria. And I think that combination is really the way to go. Some byproducts like bromate still will be retained, but largely attenuated.
Mm-hmm. So hearing like ozone is one of your favorites. So one add-on query here is, would you suggest the use of ozone UV for hospital sewage disinfection?
Was it for phage? I'm sorry?
For hospital sewage disinfection?
Yes, I suppose so. So the beauty of ozone is that it doesn't require UV transmittance. In other words, the water can be really dirty, really colored, whereas UV, the water must be pretty clear. If that water has a lot of color or turbidity, UV will not work. Ozone's much more effective. The downside, of course, is ozone is expensive. And if you're dosing it straight into a wastewater effluent, like a hospital, that dose would be very high because there's no pre-treatment if it's raw sewage. So it would be hard to disinfect it, in my opinion, but it would certainly be interesting. They may want to do some pre-treatment, but ozone's probably the only chemical disinfectant I can think of that would have a chance of disinfecting raw sewage without pre-treatment.
Okay. So here is little comparative view someone is seeking. You discussed both analytical methods and bioassay methods. From your experience, which would you be best method to monitor wastewater and water quality in terms of human health?
Oh, I really think you have to have both. So I don't think we will see, the WHO guidelines, or every country generally has their own set of standards. Those should remain. I'm not advocating to take them away. But I like the idea of including some bioassays at maybe a lower frequency, just to try to understand the mixture toxicity, which, maybe I could say it this way. I serve on the WHO. And for us to come up with one guideline can take years. It could take multiple years to come up with a guideline value. When I was in the United States, it could take a decade plus, different politicians, and it just really took a long time to get any decision making on a chemical. So I think the bioassays play a nice role as a additional safeguard. So I don't think it'll replace analytical chemistry, but it's just there to kind of look to see if there's something else causing toxicity that, especially in certain kinds of toxicity, maybe warrants a deeper investigation to try to find out what's actually there. So I think the two go hand in hand.
Mm-hmm. So someone is asking a question about the journal. If they are working on sensing heavy metals, would you look for such work into the journal?
Yeah, so analytical methods, sensors, monitoring techniques very much do fit in within our scope. In fact, the ACS is actually facilitating article transfers. And one of the journals which we get very high transfer rates from is Analytical Chemistry, where I also like to publish some of my work. But yeah, we are seeing some very good papers coming in on analytical monitoring and techniques, so it would be appropriate.
So another curiosity question here is, can we connect cases of cancer with contaminated water? Is there any existing evidence or any findings you have, or you think that's an area to create an awareness?
So there are papers that connect drinking water quality with cancer, particularly around disinfection byproducts. And I mentioned my last slide with the kidney organoids. So kidney cancer and chlorinated disinfection byproducts have been connected, also certain kinds of bladder cancers. And absolutely, chemicals like dioxins or certain pesticides we know for a fact are carcinogenic, and they do occur in drinking water. The question for things beyond disinfection byproducts is really, does the dose come mainly from drinking water, or is it from the food supply or the air quality? That becomes difficult to segregate. But if you're looking for an example, I would look at disinfection byproducts in kidney cancer. Those studies are controversial, but they've certainly been published in high impact journals.
Okay. I will pick two last questions and summarize it together because I know we are reaching the time. So this is more like a take-home message here, and someone is asking, what will be 3 advice you want to provide to a researcher working on water problems?
So let's see. So I'm going to assume water quality because that's my area. But I think the 3 things I recommend, and I'll put this in the framework of publishing, right? But I think think about taking on a piece that is within your capability to handle. What I'm trying to say is, sometimes people take on too broad of a topic. They try to solve everything in one shot. And I think for publishing, it's better to maybe go more in depth in a narrower region. For water quality, monitoring is critical. So I think if we don't have the monitoring data, it's difficult to even do the treatability studies. So, but I wanted to just add to this that I think with the advent of using fluorescence and UV, that there are ways to get a lot of data from less expensive toys, if you will, because in the laboratory I'm showing high resolution mass. I know there's probably a lot of people that have those instruments, but there are some that don't, and they get discouraged. I would say to take a look at some of the data on the fluorescence and UV surrogates, and keep in mind this idea of indicators. So maybe you pick 5 or 6 chemicals that have different properties, and you can do a really nice study on treatability or even predicting what kinds of industries are in a watershed without having to test every chemical you can imagine. So I think there's hope in there for researchers getting started.
Okay. And we have a lot of queries about joining you in PhD and postdoc. So do you have any open positions? If so, probably we can announce here, or if anyone is interested, because a lot of people are asking this question. What are the possibilities of how to work with you?
That's great. That's really flattering. So I'll tell you what, I'll send you a link. You probably can see it here on the NURI, but if you write into NURI or to me, it's probably better to write into NURI in general. We can share with people the application process. And we have a lot of great people from India here. Our group, I don't know what percent, but a quite high percent are students who have come to us from India. So we certainly welcome that.
Absolutely. And the last question I'll have, and then close the session. What type of content are you looking for the journal, or what would you encourage researcher to submit to ESNT Water?
So again, the journal is meant to be very, very broad. So I think almost any topic we can imagine related to water would make a lot of sense. So, but specific, I know we have people from various countries, but let's just take the continent of India. We would love to hear more about what's occurring in the rivers, actions, even policies, what's evolving, because I think if we look around the world, India and China, these are like the 2 biggest, I think, movements in the environmental scene. And I think there's a lot of people interested, myself included. So I think there's a lot of content probably out there we'd like to capture, especially from, I think, the people on this call. So if you have any question, whether or not your work fits in our scope, you're always welcome to send an email, especially to the ESNT email address here, and we'll let you know. But we're quite broad one, but specific to this group, I think we'd love to hear what's going on in your regions. So I encourage submissions for sure.
Thank you so much, Professor Snyder, for taking the time out and answering all the questions so patiently. And I'm sure our audiences today also enjoyed the session. We are already receiving a lot of positive comments. And be ready for a lot of emails in your inbox. Looks like you are going to get a lot of queries on further. With that, we are right on time. Thank you, everyone, for being here and actively participating into the talk. And we look forward to meet Professor Snyder again, hopefully in person sometime soon in India. Till
I
then,
hope so.
yeah, take care. Bye bye. Have a nice
Okay,
day.